All right, looks like we are live. Welcome. So we have a problem here we're looking at, and this problem should make no sense to you. If this problem makes any sense to you, then you don't need to watch this video. If it makes no sense to you, then hopefully by the end of the video, it'll make about 30% sense. And then watching it another time might make 50%. Then you got to watch it about 5 or 6 times to go from 50 up to 70 or 80%. All right, so let's start with what we're trying to do here. We want to bound something that's complicated by something that's simpler. Now, there are easier ways to do this, but that's not the point. The point is I want to show you a really simple method that can work for very complicated problems that people can't even compute or even computationally. So they look for a way to bound the problem so that we can say that the solution is less than something. All right, just like saying, for example, 1 plus 1 equals 2, but it's also less than 3. So you could say 1 plus 1, it's less than 3. I don't know what the answer is, but it's less than 3. So at least you've got some sort of upper bound to the problem, to the solution of the problem. So what we're going to do is we're going to walk through this whole process. I don't know how long this is going to take, to be honest. It's my first time. I'm sure that if I had practiced this 3 or 4 times first, then it probably would have come out better. But that's not in my nature. My nature is to just go for it, share it with you, and the fact that I do that hopefully gives you encouragement to think, yeah, let's just give it a go in a safe environment. And what people say or what they don't say, who cares? So we've got a triangle here, and let's just call these sides A. Like that coming out. Now, hopefully that's actually coming out. And we've got B, and we've got C. Is that actually working? Yes, that looks like it's working. And what are the capital A, B, and C? They're the points. So what those points mean is that if you said, for example, A, B, C, then you're talking about this angle here, right? So let me erase all of this so you can see what's going on. And what we're going to do is we're actually going to shrink this triangle by cutting it up into pieces and figure out a few things that can happen, right? So what we're going to do is, for example, first I'm going to select pen, so this will come down. Okay, you can see that. And from that, we are going to then say, now we've got two actually right angle triangles here. You'll notice we've got one on the right hand side, which if I can move this around, you can see you've got one there. Is that even showing up? No, it's not. The mouse isn't showing up. That's annoying. And you've got one there. So let's just try and get into this a bit better. So we've got a triangle here, which you can see, and then we've got a triangle there, all right? So we've got two triangles. So let's just scroll down, and that's just a little saving of what I just did above, okay? But we've lost the letters, so that's B, that's C, and this big side is A, okay? That's A, B, and C. So far, what are we doing? We're going very slowly, right? As I said, if you're someone who's done maths at year 12 or university, this is going to be very boring for you, right? But this is more for lay people to see how you can take simple patterns and use them to actually solve problems. So what we're doing here is we're going to actually name these sides. Now, one thing you probably would have learned at school is that cos of theta, and I'll explain what this means, okay, equals adjacent, which is this here, over hypotenuse. And what is that adjacent side? Well, that we don't know what it is yet. It's pretty much half of A, right? So it's half of A, which is that side. Let's just call it, I don't know, half A for now. Okay, so it's half A, okay, over B. Okay, so what does that actually mean? Well, you can rearrange that. You can put the B over here. Okay, so if we erase all of this to make life a bit easier for everybody. No, I won't erase it. I'll keep it. So we're just going to get a big mess. All right, so if we put that over here, then what are we going to get? We're going to get B cos theta. Okay, so let's now erase all of that. Okay, so far we figured out that we can call that side B cos theta. It's just rearranging things. It's like rearranging a sentence. You know, I went to the store. You could also say, at the store was I. I went to the store. Went to the store. I did. You change it so that you can exaggerate certain things versus other things, right? In mathematics, you can do that just to make things easier for whatever problem you're trying to solve. So now we can say that this side is b cos theta. That's just that side. Okay. But we also know that the whole side is a, right? The whole side is a. Well, once again, let's reword our sentence. We do a lot of this in mathematics. We reword sentences to then open up new thinking in the brain, which then allows you to find other solutions. So another solution will be like, oh, imagine in English you say, your hair is long, right? You could change that and say, how long is your hair? And that might change how you think about the situation, right? So in this case, the whole thing is A, right? This whole thing is A. Well, then what does that mean? If the whole thing is A and that little section is B cos theta, well, what's the other side? Well, the other side has to be A minus B cos theta. Right? It keeps saying it restricts me. It says it's restricting me because I'm showing other content. I don't get it. This is my own content, so I don't know what's going on there. So this side, if my pen will work, has to be A minus B cos theta. Okay. So that's A minus B cos theta. It actually happens to equal B cos theta because we've split the triangle in half. Right? So therefore, just by definition, that's going to have to be the case. So what have we done so far, right? If we go back, all we've done is we've started off with a triangle, we split it in half, and that allows us to rename all these little sides. And you might wonder, why are we doing all of this? It'll make sense in reverse. That's one of the things about mathematical proofs, is that they seem strange when you first see them, but the reason is because the people who develop them, they actually end up developing them backwards and then writing the proof forwards. So it's like, why did we start here? Well, actually, we started with the solution and worked backwards. That's normally how, I shouldn't say normally, that's a common way that someone might figure out how to prove something, by starting with the solution and working backwards and go, how do I get here? And you keep going back and back and back and back till you get to something really simple. And then when I tell you the story, I'm starting with the simple thing. So I'm like, well, why did you start with the triangle? Well, that's one of the beauties of maths. You start at the beginning, but the beginning is found from going from the end and going backwards. All right, so now we've got A minus B cos theta. So what have we got? Well, there's B cos theta, right? And because that's B. And we've got B sine theta, right? Works out the same way, B sine theta, because this side here is B sine theta. Why? Because the sine of theta is the opposite over the hypotenuse. You would have learnt that, geez, in like year 9 or year 8 or something like that. Right? And you just rearrange it and you get B sine theta. Okay, I'm not going to bore you with that at the moment. So, well, maybe I should. Maybe a lot of you haven't done year 9 mathematics. So let's give that a go, right? We know that sine of theta equals the opposite side, which is that side, over the hypotenuse. So it's B sine theta over B, which equals sine theta. So you can see that it's actually true, right? So that's why we call that side B sine theta. All right, so what have we got? We've now got that this side is A minus B cos theta. Okay, but look at that. Now we've got two triangles that mirror each other. And what does that mean? Well, have a look. Okay, well, that's what I've already drawn. Right? But if we move along, then we can actually use Pythagoras' theorem, but now on the other triangle. You're like, what am I talking about? Well, who remembers that c squared equals a squared plus b squared, right? And all we have to do is say, well, this side would be c, and then you can just call this a and b to make it simple. But now I'll erase that so we don't confuse everybody. And we're just going to take that same c squared equals a squared plus b squared, and we will say that this side, which is b squared, okay, equals, well, this side here, which is b cos theta squared, okay, plus b sine theta squared. So what have we done here? Well, that's just the Pythagorean theorem, but we've just changed the sides, the names of them, but it's the same thing. C squared equals a squared plus b squared, or in this case, b squared equals b cos theta squared plus b sine theta squared. It's just different names for the same thing, right? And you're like, okay, well, we've just changed the names. What's the point of that? Well, there's another reason. This is all going to be fascinating. I find it fascinating because just by relabeling things, you end up with a whole new formula that's even more powerful than the first one. We can do the same on this side. We can say that this thing here, which is AB, okay, that side is called AB. AB squared equals b sine theta squared plus this thing, a minus b cos theta squared. It's the same thing. We've just taken the Pythagorean theorem. C squared equals a squared plus b squared. Well, I showed you what it looked like for the left triangle, and now I'll show you what it looked like for the right triangle. So we just get this more complicated formula. And you can expand that. If you expand a minus b cos theta all squared, what do you get? Well, if you expand it, a minus b cos theta all squared equals a squared minus 2ab cos squared, sorry, not cos squared, just cos theta, plus b squared cos squared theta. Right? So you actually end up getting it here. Right. Now, this is quite interesting, right? That's what we got. It's quite fascinating. So what does that tell us now? All of a sudden we've got this new formula here, and it's actually saying that c squared, right, is a squared. What were we saying that c squared was? We were saying that, oh, ab squared. So ab squared is c squared. Okay, so we're saying that this c, and here is a, and here is b. All of a sudden we've got a whole new theorem which came out of nowhere, that this side squared, okay, equals that side squared plus that side squared minus 2 times that side times the cos of theta. What the hell? How did that come out of nowhere, right? Just by restating sentences and changing phrases and looking at things differently, we get a more powerful theorem out of a simpler theorem. This is an amazing analogy to how something complicated can arise out of something simple. And that's an interesting analogy for life, or even evolution, for example. How can something more complicated arise out of something more simple? We just had to look at things in a different way. And why did we look at them in a different way? Well, so that we got the more complicated thing. Okay. This is just a bonus. I'm not going to show this to you here, but if you take it further, you can actually apply that even if the triangle has this shape. It still works. Okay, so now we have a whole new formula. Okay. So we're like, okay, now we have a new formula. C squared equals a squared plus b squared minus 2ab cos theta. And you're like, who cares? Why am I doing this? Well, now let's look at something completely different, but turns out to be sort of the same. Okay? Imagine if you want to go northeast. Okay? Let's say we go northeast. That's northeast. And then we want to go southeast. We go southeast. Oh, I've left the screen. What does that mean? That means I end up as if I just went east. Now look at that. Isn't that strange? Doesn't that look like the same triangle? Now, let's just call this that we're going y, and this is going x. So that's called a y vector and an x vector. And in the end, when you put them together, you end up with just going east, which is absolutely amazing. And you can do it the other way too. You could say, what happens if someone else went y, northeast, and someone else went east? and we'll call that x. Okay. Well, if first person went up to y and the other person went east, how do you get them to meet? Well, they're going to have to go, like this guy would have to come down here to meet x, right? This person. Now, if that's the case, that actually turns out to be the distance of that is actually the magnitude of x minus y. Now, I'm going to show you that in a moment, right? And you're going to know what's going on. That's why you got to watch this video a few times. But so far, it's not that complicated when you watch it a few times. Just a lot of information. But it's simple steps. All we've done is we use Pythagorean theorem to figure out a more general formula. And then from that formula, I'm now showing you how you can make a triangle by vectors. And vectors are sort of a distance and a direction. So imagine person goes up y, another person goes up x. And look at that. And when you join them, you get a triangle. So we're actually turning people moving around in real space to actual geometric shapes. All right. Now this is important because, look at that. I'm going to actually change that from this example. I'm going to call this y, and I'm going to call this x. All right. There's a reason for that, just to make things a bit easier. Right? So that person went up y, that person went x. That means that the angle between them works out to be theta. Okay. Now, there's our triangle. Okay. And that's x minus y. That's y, that's x, and let's just say that's y minus x. But it's the same thing. The absolute value of y minus x and the absolute value of x minus y is the same because it's just the distance. That's why you've got the absolute value signs. Right? That just shows you the distance. Okay. Now, what have we got so far? I want to show you why this is true first. Right? The reason this is true, okay, just to make it look easy for you, I'm just going to go down here for a sec. Okay. Why is that? Well, y minus x, let's have a look. So again, I'm going to make this x, and I'm going to make this y minus x, and that's y, and that's x. Okay, so what's happened here, right? If that's y, and this here is x, what's minus x? Minus x means instead of going x, you went minus x. So instead of going east, you go negative east. Well, what's negative east? Negative east is west, right? So imagine going northeast and then negative east, which is just northeast and then west. What happens? Well, we go up here and then we go west. Right? So we went y minus x. We went northeast and then negative east. That's all that y minus x is. Right? And when you join them, that means that you actually went here. So you went up here and came back here. It's the same as going from the start here. And look at that. That happens to be, that line, this line, happens to be that one that fits right here. Okay, you just moved it across. Okay. So hopefully this makes a little bit of sense to you. Doesn't have to make too much, but you can watch it a few times. So what does that mean? Well, once again, let's just call that y and let's x. Right? And x minus y and y minus x are the same in the sense that because it's only the magnitude. We just want the distance, so it's the same thing. So remember our old formula? Our old formula was c squared, which is here. C squared. Okay, or let's just call that c to make it easy. And then this was a, and this was b. Well, what's a? A is the distance of x, the magnitude of x. And there it is right there. A squared plus b squared minus 2ab cos theta. Look at that, the exact same formula that we worked out up here. All the way up here. All of a sudden, by using vectors, northeast, east, west, distances and all of that, we've converted this formula into one that works with vectors, which is amazing because a vector is not a shape, but we've looked at a vector as if it's a shape. It's like watching someone from above and you watch them move, right? It creates a shape on the earth, an invisible shape, right? So that's what we've done. So now we have this. Look at that. All from something simple, we end up with this exact same formula. Right? But now it's in vector form. Now this is quite amazing because what can you tell about a vector? Well, look at this. Let's say I went here. Okay. So I went northeast. But you can always call that in two-dimensional space east and north. So east and north is northeast. You can always break it down that way. Right? And so even when you look at this direction, you can break that down again, and you can break that down again. Right? And that's something you might never have thought of, right? You're saying, if someone goes, I went northeast, you just think northeast. You don't think east and then north, or north and then east, right? Which is another way of saying the same thing, right? So what you can do is you can do some algebra, and you can expand these, right? So what am I saying by expanding these? I'm saying, remember this formula? Well, you can expand this side. And now we're just using some algebra. If you expand that side, what happens? Well, if you expand it, you get something almost similar to the right-hand side. Okay. And I'll show you here. You get this. Okay. Now have a look at that, and have a look at the right-hand side. They're sort of similar, except the right-hand side has this cos theta. Okay. If you look at it, they look almost the same. The right-hand side just has a cos theta here. Okay. So we will remove this cos theta. Now where are we? What we're saying is we can equate them. And because they're almost the same, they almost cancel each other out. And you get this. Why is it drawing now? I'm trying to scroll with my finger and it's drawing for some reason. There we go. Okay. You end up with x dot y equals the distance of x by the distance of y, like the magnitude, sorry, cos theta. Now this is very, very interesting. Right. Because look what happens if you divide. Sorry, what's cos theta? Now cos theta, right, looks like that. That's 1 and that's minus 1. Okay. That means that the right-hand side at its biggest is going to be absolute value of x times absolute value of y times 1. And its smallest will be this times negative 1. That means that these things are only equal, right? If I get rid of the cos theta, these are only equal when cos theta equals 1. So they only equal up this point. At every other point, this side is smaller. Why? Because cos theta is not 1, it's less than 1. So that means that something less than 1 times this is going to be smaller than this. That means that you can actually change that to an inequality, and that's what I was just showing you. So you end up with this, right? You end up with that. It's less than or equal to, right? I think I said it backwards. Yeah, sorry, that equals that times that. So therefore that is always going to be a fraction of that, and I'll show you why that's the case. Sorry, I said it backwards. Because if we zoom in, right, look at the left-hand side. X dot y equals a fraction, let's just call a fraction a half, by x by. So that means it's half of xy. For example, when cos theta moves to such an angle, I'm not going to confuse you by telling you what the angles are, right? But when that's 1, so when cos theta moves down to here, it's a fraction. When it moves to here, it's 0. It moves here, it's a negative fraction here, and it's negative 1. So you're always timesing it, the right-hand side, by something that's less than 1, unless it equals 1. So x dot y equals a fraction of this. And because it's a fraction of that, then that means it's always going to be less or equal to. Okay, because the fraction could be 1 as well. But if it's not 1, then it's a fraction or it's negative. So it's going to be less than or equal to, right? So you end up with this, which is quite interesting. Now this is the absolute value. This is a bit different because what we're saying is we're only looking at the positive component. So it's the same thing. That just makes it that cos is either 1 or a fraction or 0. So that you're going to get this inequality. So what did we do? We went all the way from the beginning to show you. We went all the way up here. We started with a triangle, split it up, reworded the question, ended up with this equation, and then we turned it into vectors. And by looking at the vectors, we realize it's the same equation, but then we can expand this x minus y on the left-hand side, and then the two sides cancel out and simplify, and we end up with this inequality right here, right? And all that's saying is that, okay, we sort of got that, which is quite fascinating. So we've gone all that way to get this. Add the second pair. Anyway, I won't bore you with that at the moment, summed inequalities, right? So I'll show you this thing. Why has this been here the whole time? I wanted to show you this. So if you look at this particular thing, you will see that u dot v equals magnitude of u, magnitude of v. I've just changed x and y to uv here. There's a reason I do that later. It's a mathematical notation that I've done for... Anyway, x1, y1, x2, y2. What are we saying here? Remember that we were saying that... Let me shrink this down. Oops. Excuse me while I shrink this down. Remember we were saying that x, right, if it's northeast, then you could say north plus east, okay? And then we just call that in mathematics x1 plus x2. Okay, so x equals x1 plus x2 because x is two-dimensional, which is northeast, right? It's made up of two independent vectors. And then we call that x1 plus x2. So if we say x dot y, and in this case we're calling it u dot v, then that's going to equal x1 plus x2, okay? But x1 plus x2 is x1 times y1, x2 times y2. Now you're going to go, what has just happened there? Okay, what we're saying is this. We're saying, let's say that y, right? Let's say that x is northeast and y is northwest, okay? So we want to multiply northeast times northwest. Well, how do we do that, right? Well, we can break it down into its independent components. So northeast we just say is x1 plus x2 times, and it's actually a dot product by y1 plus y2. So it becomes x1 y1 plus x2 y2. Okay, so the distance that went north we amplify it, and the distance that went east we amplify it. That's what we're doing, we're amplifying them, right? So we end up with this triangle that I wanted to show you here. So that was the uv, right, that we were saying, that it's less than or equal to uv cos theta. Now this is fascinating because here is the actual uv, and you can see that this side is never equal to that unless they're the same line, which means cos theta is 0. But here cos, that's theta in there, and cos theta is adjacent over hypotenuse, and we simplify that. We call this side u, magnitude of v, cos theta, okay? And we end up with this side. So that was the triangle in the end. We get this. And what we're saying is that this side is always going to be longer than this side unless the angle is 0 and they fall on top of each other and then they become the same length. Okay? But you can also break this into this, which is what I was just showing you. So I've showed you it's a smaller triangle, right? U cross V. That was the north component for x, the north component for y, and here is the north component, the east component for x and the east component for y. Okay, and you end up with this triangle. But what you can see is that we get this inequality, and that was all it is. That whole thing is just to show that we get an inequality. So then we want to say, well, how do we end up solving that original problem? Well, this is the beauty of it, right? Let me shrink that again. Now we can go to the original problem, and you're like, what is going on here? Well, now I'm going to write it for you in a way that's going to make sense. Okay, hopefully. So we look at this and we say, what's this? K equals 1 to n. Let's just call n 2 for now, just to make things easy. Okay. Now, if that's the case, that equals a1 over k1 plus a2 over K2, right? But we know that all A's are not bigger than this value called M. So that's less than or equal to M over K1 plus M over K2. And that's because each one of these is either the same size as M or smaller. So then they have to be the same size as this or smaller. Okay, that's like saying, for example, 1 over 3 plus 2 over 3. Well, the biggest value here is 2. So that's going to be less than 2 over 3 plus 2 over 3. Okay? Because we took the biggest value 2. So this is just the same thing but with letters. Okay. Now, notice that you can now take out the M here. So you can say that M outside of 1 over K1 plus 1 over K2. But now it looks like we've sort of got two different things here, right? So we can use that inequality. I know there are simpler ways to do that, right? But we can use the inequality. So using the inequality, right, what we do is, let me find an easy way to show it to you. Okay, let me find something easy. Okay, so let's have a look here, right? Let xk equal ak and yk equal 1 over k. Now the inequality allows us to split both sides because we know that the left-hand side is smaller than the right-hand side. And the right-hand side was the magnitude, if you remember, right? We had that x dot y is less than or equal to the magnitude of x and the magnitude of y. Okay, that was our thing. So what we've done is we've taken something that's mixed together and we can separate them. And that's all we've done, this whole thing. So we've taken this which is mixed, and that's that, and we separated it into that. Okay. There's actually more maths I haven't showed you, right? Because I haven't showed you the full story, but that's okay. I won't show you that for now. This is more so that you can understand what's going on, right? But we are given that this is true. Now, if that's true, that means that we can shrink y into this. Okay, that means that we've now just got that. So what are we saying? We're saying that, well, we know, as I was saying about m is the biggest one, possible biggest one. Okay, and that's like saying, for example, imagine a1 plus a2, right? Imagine a triangle. a1, a2. Well, none of these can be bigger than m. Okay, or they can equal m, but they can't be bigger, so m is the max. That's how you can look at it on that case, right? So you end up with another triangle. But long story short, we know that that's that. So therefore that has to be smaller than that. So now our bound is this. And that's our two things right there. That's our magnitude of x, and this is our magnitude of y. And there it is. We've now bounded by that. So now we know, without even doing a calculation, we've shown that this whole complicated thing up here has to be less than or equal to this number. So when you're dealing with very complicated problems at university, sometimes you don't want to do the calculation. You just want to know, look, what number is it less than? And then I can just work with that number and say that if you have a big problem, and in this massive problem, in the middle of that problem, you end up with this thing. And you're like, I don't have time to solve this, or it's going to be too much, or it might be even impossible because it's like really complicated in like something in real life. You say, okay, well, what I'll do is I'll simplify the problem by saying that the problem is going to end up being the component of the problem that was that really complex section. It's going to be less than or equal to this number. So I can just plug the number in. If I have a massive problem and inside the problem is this thing, I can just replace that with one number. And it just collapses the problem so much more. Of course, it increases inaccuracy because now you know that it's less than this number. You don't know how much less than a number it is. But there you go. That's a very long way, and hopefully you've understood about 30%. If you've understood 30% of what I'm saying, then you've done really well. I mean, for those of you who've already studied maths up to year 12 advanced maths, this is all nothing to you. So why are you here? But for the layperson, I think if you've understood 30%, then you've done amazingly well. And then after watching it 5 times, I think you'll get up to 50, 60%. That's normal. Even for like extremely bright people, that's normal, right? So enjoy. I hope you found that enjoyable. And yeah, we'll talk to you next time. Take life one smack at a time.